So this is section 3.6, which is mathematics of finance. So we're going to talk about simple and compound interest, interest compounded, we're going to say n times per year instead of k times per year, interest compounded continuously, annual percentage yield, annuities, future value, and loans and mortgages present value. Okay, so this is one of those real life applications. So a lot of times it's hard to see where we're going to see math in the real world. This is one section that is directly related to money, finances, all of those things that you will deal with as an adult. These are important things to know. So the first thing we're going to talk about is interest compounded annually. So this equation right here would be just a simple interest formula. And then this would be our interest compounded annually formula. So in our first example, we're going to see the difference between this. So it says, suppose George Milligan invests $5,000 at 5% annual simple interest, and Quan Lee invests $5,000 at 5% annual compound interest. Compare the values of both investments after 10 years. So what we're going to do is we are going to, so for George, we would take, so we would say A equals, and we would have our 5,000 times 1 plus, and then we would take our 10 years, times the rate as a decimal, so it would be 0.05, and that would give us 7,500. Okay, and then Quan, we would use our compound interest formula. So this would be 5,000 times 1 plus 0.05 over, oh, we don't need to put the over 1 because it's just yearly, annually. Whoops, 0.05 raised to the 10th power. So that's going to give us $8,144.47. So the interest that, it says to compare the values of both investments. So Quan earns $644.47 more. Okay. So the next thing is, so this book uses interest compounded k times per year. The equation was slightly different. I want to be consistent with the equation you've seen in Algebra 1, in Algebra 2, and now again. So I don't want to go and switch variables on you. So this is the formula that you, that's my dog chasing my cat. Okay, that I don't want to switch values for you. So compound interest n times a year is what we usually say. So A equals P times 1 plus R over N raised to the N times T. So I'm trying to keep the letters consistent with what you've seen in the past. Okay, so suppose Paul invests $400 at 8% annual interest, compounded monthly. Find the value of the investment after 5 years. So this would be 400 times 1 plus, we turn that percent into a decimal, so 0.08. Monthly means our n value is going to be 12 raised to the 12 times 5. Okay, so we type all that into our calculator, and you should get, so that's the one thing. I would double check that you know how to type this into the calculator, because that can be the tricky piece here. So this, you should get 595.94. So that is that problem. Then our last formula that should be familiar is the PERT formula. So PE raised to the RT, and that's when interest compounds continuously or exponentially. So if you see the word continuous or exponentially, that means you're going to use the PERT formula. So now we're still talking about Paul investing $400 at 8% annual interest, compounded continuously this time. So this would be 400 times E raised to the 0.08 times 5. And that would give you $596.73. So you will notice when we compounded continuously, he ended up with $596. And if we go back, when we compounded monthly, it was $595. So the more frequently you compound, the more money you're going to end up with. So that's just something to keep in mind. So annual percentage yield. A common basis for comparing investments is the annual percentage yield. So the percentage rate that compounded annually would yield the same return as the given interest rate with a compounding period. So we're going to look at some examples of this. So suppose you invest $1,500 at 6.25 annual interest compounded monthly. What would be the equivalent APY? So if we let X equal our annual percentage yield, so for 1 year, with this situation, we would have A equals 1,500 times 1 plus X. Okay, so that means if we set up our equation here, we're going to say 1,500 times 1 plus X is equal to 1,500 times 1 plus our rate, so 0.625 over 12, because it's compounded monthly, raised to the 12 times 1 year. That's a multiply. Okay, so then if we divide both sides by 1,500, we're just going to have 1 plus X equals 1 plus 0.0625 over 12 raised to the 12th power. So then we would get 1 plus X equals 1.0643. Okay, and then if we subtract 1 from both sides, we can tell that X is 0.0643. So if we put that back into a percentage, oops, didn't mean to do that. If we put that back into a percentage, we get 6.43%. Would be our annual percentage yield. Okay? So then we have two equations that we're going to look at. We have future value of an annuity. So this equation right here represents the future value of an annuity. So you can see that FV is our future value, N is our equal periodic payments, R is the amount of each payment, and I is our interest rate. And then we have present value of an annuity. So same variables, but different equations slightly. So we're going to use this to talk about loan payments on a vehicle. So we have Carlos purchases a pickup truck for $18,500. What are the monthly payments for a 4-year loan with a $2,000 down payment if the interest rate, the APR, is 2.9%? Okay. So what we're going to do is we are going to, first of all, if he has a down payment of $2,000 and the truck value is $18,500, we know that the amount borrowed is actually $16,500. Okay, and then to find I, we are going to take our APR, so we're going to take our 2.9%, except we're going to write it as a decimal. And we're going to divide it by 12, because that is the whole year. And we want to know, we're talking about monthly payments. So if we divide that by 12, we get 0.0024. Okay, and then N is going to be our number of payments. So we know that there's 4 years of payments and there's 12 months in a year, so that gives us 48. So we're going to set up that equation from the previous slide. So this is going to be 6,100 equals, we're trying to find R, 1 minus 1 plus 0.0024 raised to the negative 48 over 0.0024. So that whole value we can type into the calculator because there's not a variable in that, so we can get that value. So we end up getting 45.287 R. We can divide both sides by the 45.287 and we get 364.34 cents. So that would be your monthly payment. That would be Carlos's monthly payment for that scenario. Okay, let me know if you have any questions.